Okay, the main objective today, what I'm going to discuss is, okay, so today agenda I will discuss. Okay, the first topic what we are going to discuss today. So we will do more lab guys today. Okay, the first lab will start from the static routing. I think last week we did using the 2 routers. This time we will use the 3 routers. Okay, and we also configure DHCP, telnet, and with single access. Okay, then default routing also will do. Okay, default routing. And your third topic, I'm going to start with the RIP. Then fourth topic, I'm going to discuss the EIGRP. Okay, and the fifth topic, I'm going to start with the OSPF. Okay, in EIGRP, we'll do the 2 labs. Okay, with the 2 routers and 3 routers. Okay, same thing for here also, we'll do the 2 lab. Okay, with the 3 routers and 2 and 3 routers. Okay, and here also we'll also configure your MD5 authentication. Okay, so using loopback also we'll make it. Okay, guys, using loopback also we can able to do it if we have time. Okay, we'll continue with the redistributions like OSPF, multiple area, and redistribution. That is redistribution OSPF to EIGRP. Okay, and EIGRP to OSPF. And other one is we shall also configure EIGRP to RIP to OSPF. Okay, and BGP is not there in the CCNA, guys. This is actually in the part of your CCNP. Okay, and tomorrow maybe we'll do the ACL, access control list, and NATing, dynamic NAT, static NAT. In ACL, we also configured your standard extended name list. And we also discussed the WAN technology, wireless. And wireless also we shall discuss. And next will be switching part. Switching part maybe next week, most probably, we'll see. Next week possible, this is not possible because this is a very huge content, guys. The content is very huge. Okay, and today we'll also do these 3 labs. Okay, I'll show you the very simple way to configure the static and the RIP configurations. Then we'll jump for the EIGRP. Okay, the content is very huge. Okay, as you know that it is live recording, it is live on Facebook. Even I'm getting recording this content also. Later on also we can able to watch these videos. Okay, and the switching part, we shall discuss the basic switching concepts like inter-VLAN routing, your spanning tree protocol, per VLAN spanning tree protocol, rapid spanning tree, MST, DTP, virtual trunk protocol, router on stick, ether channel, that is port channeling, your securitying the devices. Okay, we'll also discuss AAA, radius, and TACAS. Okay, these are the actually complete syllabus of your CCNA part, guys. Okay, so I think it will go up to your April first week or second week. Okay, so you need to cooperate with me, guys. Okay, the content is very huge. I don't know how many, because very less people are joining, because I'm expecting around 60 people they have registered. So only I think they have joined 10 people today. Okay, I don't know what is the reasons. I think like African people, they have got a lot of money. They want to pay and they want to learn. I don't know why. Malis, you have to tell me. Okay, guys. So this is the content like which we are going to discuss in coming session, guys.
Okay, sir.
Yeah. So now, last week, before I could start, last week we had discussed which all the topic, guys. So do you remember? We have discussed the IP addressing, and we have done some basic configuration like the basic configuration for static routing. Do you remember?
Yes, sir.
Static routing last week. Let's discuss this so that people can understand what we had done last week. So last week we had done some IP addressing, right? Okay, IP addressing, and second topic we had discussed some static routing.
Default routing.
Okay, and we had done with also with default routing. So we also done with default routing as well. People are joining now, guys. Okay, I think this are the topic. The last week we had done very less, man, right? So today, guys, so as you know that, and today's agenda will be, okay, we shall discuss right from your static routing. Okay, and we'll also default routing I'm not going to do, guys. So directly jump for your RIP. Okay, so then we'll jump for your EIGRP. Okay, in EIGRP we'll do a lot of labs. Okay, so EIGRP MD5 authentication. Also we'll do EIGRP with the loopbacks. Okay, EIGRP using like 3 routers. Okay, then we'll jump for the OSPF after the break. Okay, these are the topics which we are going to discuss today, guys. Okay, so let's start, guys. Okay, I think static routing, yesterday we had done some basic, last week we had done some basic configuration using the 2 routers. Okay, I think last week, let me open the Saturday, Sunday batch, right? I think we had done static default with using 3 labs we did, right? Let me open one of the lab. This is the lab I think last week we had done, right? Okay, this is the topology what we did. Okay, if you want, I will repeat this one, or else I will jump for your directly EIGRP. Okay. This is the last week lab, what we had done, right? Okay, so what I'm going to do now, I will take the same topology. Okay, let's say, I think, open second one. Yeah, using these 3 routers, guys, I think I will take this topology. Now, because, you know, there is one new guy has been joined today, because let me do right from scratch. I'll copy and paste. Okay, so this is our let me rename this. And this is my EA static routing lab 4. Okay, so this is my static routing 4. Okay, what is the static routing, guys? Who will explain? So the administrator must know the entire concept, entire network architecture or network topology to configure. Okay, the administrative value for static routing is what? The administrative distance for the static routing, okay, is 1. Okay, if it is directly connected, okay, as we can see, these 2 switches are connected directly. Okay, the AD value is 0. Okay. If it is 1 means that is your static routing. As we can see already mentioned here, for the RIP, AD value is 120, for EIGRP 90, OSPF 110, IBGP 200, EBGP is 20. We have to remember, guys, these are all the interview questions if you apply for any job for your organization. Okay, so let me jump for the lab, guys. So what I'm going to do, I will configure the same thing. So just I will remove some basic configurations. I remove the static routing. Guys, how to remove the static routing, guys?
Just no.
Just no, right? Very good. Okay, go to global configuration mode. Okay, check do show run. What are the configuration we are running here? Okay, we have configured DHCP and we have configured some telnet as well last week. And we have assigned the IP address. And we have configured, I think, static routing we have not configured here. I cannot see static routing. Let's check the configuration. Okay, do show IP route. Okay, so we have not configured anything here. It is totally new topology. Nothing is configured. Just DHCP has configured. Show IP route. We can see it is all directly connected network it's showing. Only directly connected network it's showing. So we have not configured anything yet. Okay. So type IP, show IP DHCP. Okay, so IP DHCP, I don't know what is a pull. Okay, DHCP also configured here. So let's check whether they are getting the IP address or not. Okay, we are getting 1.4. Perfect. And what about the server? Yeah, server is 1.2. And yeah, so this one also we got it the IP address. So let's check this side. Yeah, so these two network, right? Two networks, we got the IP address. Yeah, so we are getting the IP address. Okay, so check whether we have configured DHCP on the server, right? We have configured DHCP. We have not configured DHCP on server. So as I told you that, I recommended to configure the DHCP on your server, guys, not on the router. Okay, in coming topology, guys, in coming sessions, we'll configure only on servers, not on the router. These are recommended by Cisco itself. Okay, so let's configure the RIP, guys. I'm going to configure the your static routing. So now you can see if we check the connectivity, so we cannot ping from my this PC to this PC. There's no communication between these two different network. No communication, but inside network, they can communicate. So inside their network, they can communicate with each other, not with the different network. Okay, now we'll make them communication with the other network. So how do I configure that? How do I configure, guys? Very simple command, right? So go to global configuration mode, IP route. Okay, first understand like where to where I should configure. So let's make it small. So IP route to reach to 2.0 network, that is 192.168.2.0 network. So give the subnet mask. Okay, go via which IP? 1.10.1.1.2, correct?
Yes.
That's it. And same thing from router 2 as well. Okay, so from the router 2, how do I configure? So go to global configuration mode. So IP route to reach to one network from this side. To reach to one network, give the subnet mask and give the next hop. Next hop is 1.1.1 because this is the 1.1.1. Correct. This is the 10.1.1.1. Done. So show IP route. Now we can see now it has been learned. So let's check from this side. Let me increase this so it will go. Show IP route. Okay, so now I can able to reach to the network. Correct. So now you check the ping and go to this PDU. Okay, as you know, the first packet will be dropped because it's learning the your ARP replay. It takes time. The second time you can able to reach it. Okay. If you click on the routers from here also we can able to ping. So I can ping to two network. So example 2.2. Okay, so I can reach. So 2.3. Okay, I do have the communication. So suppose if you type trace route, so trace is a command. So how the packet is moving. So example, this is 2.5, one of the networks. How the packet is moving. We can see. So it's moving first is moving to the 10.2. Okay, then it's going to this network. So 2.5. I don't know who is the 2.5. Let me check. This is 2.2. Yeah, this guy is 2.5. Same thing as if you check in real also. Okay, so trace route, say example like google.com. So how do you this one command, guys? So trace route in the real time. Malice, can you tell me?
Yes, sir. What was the question?
Malice, you tell me that how to trace the Google, how my packet is moving.
First, it goes from your PC to switch, then to the router.
Yeah. Not from the
Then
I want to ping for the real.
for the real.
Yeah. I want to see. I can able to ping, right? Google.
Yes.
Okay, I'm getting reply. Means I do have the connectivity because it is connected to the internet. It's all my
Yes.
PCs, all we are connected to internet. So now I want to check how this ICMP packet is moving. Which are the hop count?
What do you mean by saying moving?
Packet,
can
how
go
it's
to-
hops,
moving.
number of junctions. How your packet is going from one destination to another destination. What are the different station will come? Say example, guys, if you want to come to Africa, there's no direct flight from Bangalore to Africa. Whether I should go to Dubai, from Dubai to this thing. Suppose if I do the trace, okay, how I have reached to your place, show you I went to from Bangalore to Dubai and Dubai to your Malawi or any Tanzania, any African countries. Malice, can you tell me?
Yes, it goes to first your router, so it is not internal network, so it go out. So it will show you every router's IP. When you trace it will show you first. It goes to the first the router you see in your local network. Then it will go to other side of like one network. Then next it until it finds it will show you some IPs of the routers. Until it reaches its destination.
Okay. Okay, you tell me what is the command because it's showing some error.
The command is trace RT. Trace RT.
Yes.
Trace RT.
Trace
RT.
RT. Then www.
Then you can Google.com.
Is it correct?
Yes.
See, I'm getting like 30 hop counts. If you see, I'm getting 30 hop counts from my Google to reach because it's going to my Wi-Fi router. I have the routers dealing and it is going to my public network. So it's taking time, long time. Okay, request timeout. because it will show you like how the packet is going from one destination again next destination to reach to your destination, actually destination. Okay, it's a very simple lab, static. Last week also I did. Correct, guys?
Yes.
Yeah, so I think a telnet, I don't know whether what telnet we have configured here. Show run. Username Clara. I don't know what is the password. Do you remember, Clara, what is the password?
Cisco.
Cisco. Let me think. Let me check. Go to desktop command. Telnet 192.168. I think 1.1. CLA, right?
Yes.
Cisco 123. Yes, perfect. Cisco 123. Okay. So now I am able to access my network router. What about can I say example, I am the network engineer here. I want to access this another organization. Say example, okay, this is my IBM company. And this is my Dell. This is Michael Dell. Yeah. So can I able to access this router from another network? Isaac, can I able to access this router, IBM router? I want to access the IBM router. Can I access?
By doing telnet.
Yes.
You switch the IP, the outgoing IP for the router of
CLA.
sorry.
Is it am I able to access, right? Correct. You can see on the screen, right?
Yes.
Okay, so what do you understand here, guys? First understand, because if I remove the routing protocol, so let's say, so I will go to global configuration mode. Okay, I say no, I'll remove this routing protocol. I say copy and paste. There's a no route now. Show IP route, no route now. So can I able to ping now? Can I do the telnet? It's gone. See here, connection timeout. A remote host not responding. Let's try once again. It's trying to send the telnet message. I want to access, because there is a no routing protocol, means there is a no communication between these two different network. You can see it's not responding. Okay.
Yes.
So can I go for next lab, RIP lab now? So let me save this. Okay, I think last week we did now. So today we'll do the new lab. Okay, so what I will do, same lab, I will RIP lab 1.
Sir, can I ask you one question?
Yeah, Malis.
We last time, as you told us, we just configured and we didn't configure routing and anything like that. So we can use that one, right? We already assign IP address, DHCP.
Yeah,
everything.
because everything same. Just remove the configuration, we can do it. So what I will do is I'll remove the static routing here. Guys, don't get confused. Just I'm removing the previous configurations.
So we don't need to use the static configuration.
Yeah, right from configuration, no need to use a show run right from scratch. See, what I will do is Okay, just I remove my previous configuration, what I did. So previously what I configured just static routing here. I think this is a new topology, right? We have not configured anything. If you try show IP route, so nothing is configured. This is my router 1. Okay, a router 2. Okay, so here also, I think nothing has configured. Show IP route. Okay, static routing has, I think this guy has configured. We need to remove this. We can see, right? So static routing we can see here. So just remove that. Okay, this is the thing where we configured. Okay, so copy. So go to global configuration, type no and paste. That's it. Now we cannot see. Okay, now there is no communication between these two guys. There is no communication. If you type, take this PDU and put it here. No communication. Okay, we cannot communicate with each other. So now I am going to configure what? RIP. Okay, DSCP telnet here. Just I'll remove this just to avoid the confusion. Also, I'll change the color also. Okay. RIP. Okay, just I have made just one change. This is the IBM company, and this is your Dell company. Remaining all are same. Okay, it makes sense, guys. The RIP now. So if you want to change the color, so let me change, because just to avoid the confusion here also I'll remove. So that you think maybe I'm using the same topology. Okay, I'll make it short. Then let's fill the color. Let's take this blue color. This is one network. Just this is the green. And center one will take yellow. Okay, now this is different now. This is, I'm going to configure your RIP. Okay, so before I start the RIP, guys, please tell me how the RIP is going to work. What is RIP? Routing Information Protocol. What is the AD value? Last week I told you, right? Do you remember? What is the AD value for this? For your RIP, the AD value is
120.
120. Then routing information protocol. Okay, the RIP is going to work up to maximum hop count. How many? 15 hop count.
Only 15.
Only 15. Okay, 16 is unreachable.
Unreachable.
Is going to work based on the number of hop counts. Okay,
What
this
is hop count? Sorry.
yeah, I'll tell you. What is a hop count?
This
okay. This is my router. Yes, this is how connected. Okay, as you can see right now, I am using how many? 3 routers. Correct. Okay, this is my R1, this is my R2, this is my R3. Okay, this is the hop count 1, 2, 3. Like this, it will work up to 15. If you connect 16, okay, it will not do the communication.
Okay.
This is the hop count. RIP is going to work based on the number of hop count.
Okay.
And the metric calculation will be done number of connected router. Maybe you connected one more router here. Maybe you're running some big network inside your connection, lot of PCs, servers are connected. So metric will be calculated based on your number of connections. This is how a RIP is going to work. Okay, the most of the organizations, so RIP is not recommended because of the higher administrative value. Okay, the lower the AD value, it is a better communications. The RIP is also come under your dynamic routing. So it will come under your dynamic routing, guys. I hope it's clear, right? So
Yes.
okay, so let's configure this RIP now. The configuration is very simple compared to your static routing. Okay, so because right now we can see how to check the IP address, guys. Show IP interface brief. Okay, show interface IP brief, because right now we have configured 1.1 network. Okay, 10 network. Okay, there is no communication inside now. Okay, so how do you configure? So go to global configuration mode, router RIP. Okay, if you check, give the question mark. Okay, so in this router, you can able to configure these 3 routing protocols, which are these BGP, EIGRP, OSPF, and RIP. These 4 protocols you can able to configure. So right now we are going to configure the RIP. Okay, so now how do we configure this? Just we have to authorize your internal network. How do I authorize network? What is your internal network? This is your network. You can see, right? 192.168.1.0. If you give the question mark, done. That's it. Okay. And there is one more network. What is that? 10.0.0.0. That's it. Show IP route. So still it is not reading that. Okay. Means we have to configure this router as well. So let's configure this one as well. So go to global configuration mode. Okay. Router RIP. Network, just you have to authorize your network. That is 2.0 network. You can see, right? This is your 2.0 network. That's it. And one more network is 10.0.0.0.
We don't add the subnet mask.
Not required. Okay, we can see, right? Show IP route. Can you see the R, right? On the screen. We can see the R, right? So these R indicate, okay, it has been learned your router 1 network. That is router 1 network is 1.0 network. You know what is this value?
AD.
This is called your AD value. So what does it R indicates? R indicates your RIP.
RIP.
R indicates your RIP. Got it? Okay. Now you check from other router now whether this guy has learned. So previously he has not yet learned, right? Now repeat the same command. Use the upper arrow mark key. So repeat the same command. So now we can see this guy also learned 120. Understood, guys? So now
Yes.
we can see, I think we can able to reach to 192.168.2.1. Okay, I do have the reachability. They have the perfect communication. We can see the previously it was showing fail, right? We can see, right? On your screen, previously it was showing fail. Now, if you ping once again from this desktop to this desktop, the first packet will be failed, and second time if you ping once again, so now we can see it has success. Okay. So if you want, we can check ping from my server to server. Where these 2 servers, they have that reachability. Yes, I do have the reachability. This is the RIP, guys. Okay, routing information protocol. If you check from laptop to laptop, as you know, first packet will be dropped. I can ping once again. So I do have the reachability. They have the perfect communication now. Understood, guys?
Yes.
Okay. So can I jump for the next lap now? Now
Yes.
I will do with the 3 routers now. RIP. Okay, I will take this RIP again, copy and paste. Okay, very strong, powerful command. Okay, RIP lab 2 using 3 routers. Okay, if you open this, same topology will be open. Okay, so I'll put it here, this one. Just I want to add one more router here. Okay, so I will take one new router now. So let's take this one. So I'm sure, I think this router has not got the serial model. You can see, right? There's no serial model inside. So what we should do, off the router and add the module on it. So now we can able to connect your serial cable. Okay. So now this side, okay. So I will not connect any PC, guys. I will create the loopbacks. Okay. So here, what I'm going to do, I think someone is waiting in the room. Let me check. Yeah, no one. No one is waiting here. So here just I will create the loopbacks. So I'll give the IP address. Say example, this time I'll give 20.1.1.1/8. And this is your 20.1.1.2. Okay, and loopbacks, I will create some loopbacks here. Just write in capital. Loopback 1. Loopback 1 IP address. Let's say I will give 192.168 3.1/24. Okay, so copy and paste. And loopback 2. I will give 4.1. I'll create totally 4 loopbacks. This is 5 and this is 6. Okay, so I'm not going to. These are the loopbacks are running here. This is, it is, we can consider as a loopback. Just we are using the loopback 1, 2, 3, 4, 3.1, 4.1, 5.1, 6.1. Okay, so guys, please pay some attention. This is quite useful lab. Okay, so we can see right now, I think some basic configurations we have to remove that. Okay, show IP route. Okay, as we can see, RIP is working now. How do I remove RIP, guys? Go to global configuration mode. No router RIP. That's it. No router RIP. Alas. Same thing, this router. So go to global configuration mode. No router RIP. That's it. Now, if you check, now they will not communicate. Let's say server to server, fail. Again, if you ping server to server, fail. Means they don't have the communication now. Laptop to laptop, no. Okay, I have removed the communication, right? So let's configure this router now, because we have to give the IP address for this interface, then this interface, and this, in this router, we have to create the 4 loopbacks. Okay, so let's do that. So this is my router 2. Okay, so I need to enter to the interface. interface. Which interface? Serial 0/1/0. Okay, give the IP address, that is 20.1.1.1. Okay, 255.0.0.0. Okay, we have to set the clock rate, right? Okay, so as I
Sorry.
can see, yeah,
The interface of 0/ interface is serial 0/1 0/1/0. But you put the IP for the interface is 0/1/1.
okay. What mistake I did, guys? What was my mistake
Change
here?
the IP address. The IP address 10 range. Use 10 range from this one.
Right, because I enter into the wrong interface. See here,
Yes.
right? We
It
can
should be
see, right?
router 2.
It should be 0/1/1. You can see, right?
Yes.
Because you are very fast. You are very fast.
Okay, I'll slow, man. No problem. Because I'll be slow now.
Thank you, sir, for saying very fast.
Okay, let me on my this thing screen. Like, okay, I'll go slow, man. I forgot to on my camera. Now you can see me, right? Let me have some interactive session, guys. See, I had done the mistake because for the wrong interface. I think you will also face this issue, guys. Okay, it will be basic mistake. Let's say do show IP interface brief, because it has considered that guy as a C. It has taken this IP address now. Okay, so what we should do, no IP address. Okay, then IP address, that is 10.1.1.2 255.0.0.0. Yes, so give no shut. Okay, now we have to enter serial interface 0/1/1. Okay, so now
Yes.
we have to enter into your 0/1/1, then IP address 20.1.1.1 and give the subnet mask. Okay, so now we can give the clock rate. Clock rate we can give, this time I'll give 56,000. Okay, I can give no shut. Okay, router 2 configuration is done now. So let's configure for your router 3. So which is the last router now. So this is right from scratch, guys. I say no. This is a new router now. So global configuration now, I will give this this is my R3. This is my router 3 now. So I'll go to this interface serial 0/1/0. We can see this interface, right?
Yes.
We can see on the screen. Okay, what is the IP address? 20.1.1.2.
2.
Okay, what is the subnet mask for this?
25.0.0.0.
0.255.
55.0.0.0.
Yeah, so I say no shut. We can see the interface is coming up, right?
Yes.
Okay, what next I should do now? What is the next step? Who will tell this answer?
Now configure OSPF.
OSPF. Melis, where are you, man? You are in Ethiopia or where? You are in heaven, I think. We are not doing OSPF. We are doing still RIP with the 3 routers. Previous lab we did only RIP for only 2 routers.
Why
Configure
you take clock rate in the we use it for RIP is
Just the
only
bandwidth.
for
Melis, where are
yeah.
you?
I am in Ethiopia.
You are in Ethiopia. I think you are not in Ethiopia, man. You are in you are in heaven, in paradise.
I am doing configuration to my
We are not doing OSPF, man. We are doing RIP, routing information
no
protocol,
problem.
using 3 routers. Previous lab we did only 2 routers. This lab
But-
using
okay.
3 routers with the loopbacks.
Okay.
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 Okay. So now I should create loopbacks now. correct? Interface loopback 1. Okay, what is IP address? So 192.168 3.1 255.255.255.0. Correct? For loopback, we should not use any no shutdown. The moment if you create the loopback, automatically it will come up because it is a virtual interface. This is not a physical interface. Okay, the same thing for loopback 2. Okay, this is my 4.1 and loopback 3. And this is my 4.2 and this is 5.1 and one more loopback is 4. And this is my 6. So right now, how many loopbacks I have created? Do show IP interface brief. So we can see these are the list of loopbacks what we have created.
What are those for? Remind me,
Yeah,
what are those loopbacks for that router?
these loopbacks are the virtual interface. It is used for testing. Okay, so let me explain this. Okay, why the loopbacks are used is very important. See, say example, this is my this is my organizations. Okay, so you have one department here and there is a one more department, this is one more department and this is one more department. Okay, so each one is connected like this. Okay, and here also you are running some lot of interfaces. Now the question here is what happened? Okay, we cannot use the real devices. Maybe you are connecting a lot of routers are inside your organization. Say example, this is your HR, this is your management. Okay, this is your IT team, and this is your sales team. Okay, before implementing the real IP addresses, we will use the loopback for as a testing. Same IP address what we have configured here, same thing will be implemented. Loopback 1 here, loopback 2 here, loopback 3 here, loopback 4 here. So like this, we can able to configure. The other reasons we are using just for testing. Once this testing is working perfectly, this all working, okay, then the same command will copy all the command and paste it here in the real devices. Okay, loopbacks are quite very important. The loopback range where it starts from, by default it is 127. Correct. The loopback range. Understood,
Yeah,
ma'am?
okay. Yeah,
Okay, it is used for testing. It also used for the router ID. Okay, as you know that this will never go down, right? This will never go down because it is a virtual interface, right? It is a virtual interface. Your physical interface may down at any moment. Okay, that's the reason. Okay, we are creating the loopbacks now because previously what we did the RIP configuration by using a physical. Now we'll create for the loopback for your virtual interface. Okay, let's start about say example. This is my say HP Helvet packet. Okay, so let's start first my IBM router now. Okay, so now I'm going to configure your RIP. So go to global configuration mode. Okay, router RIP. Now tell me which are the network you have to authorize. First understand this before I jump for the lab. Right now I'm in R1 now. Okay, now you tell me like which are the network I should configure. Okay, how many network? This is my network 1. Okay, then this is my network 2. In R1 I should configure, correct? Okay.
Can you repeat?
Okay, in router 2, in my Dell router, okay, I have to authorize this network 1. This is my network 1. Okay, and this is my network 2, and this is my network 3. I have to authorize myself. Okay, in HP router, okay, I have to authorize network 1, 2, 3, 4, and 5. Means totally 5 5 network I should authorize. Understood, guys?
So on HP side, you have 5 network.
Yes.
Okay.
Right. This is 1. Okay.
And the other 4.
This is 2, 3, 4, and 5.
So how many total
Hmm.
networks for that topology?
Which topology?
This one, the 3 routers,
Okay.
total number of networks.
Average 10.
How many are there? You just count and tell me. Okay.
Fine.
This is 1, 2, 3, 4,
Totally 8.
5, 6, 7, 8. Total 8 network are there. So totally we have total 8 network. Okay. So let's configure on first my IBM router now. Okay. So network 192.168 1.0 network. Then 10.0.0.0 network. That's it. Now router 2. Router RIP network 192.168 2.0 network. Then network 10.0.0.0. Then network 20.0.0.0. That's it. Okay. Now router 3. So router 3, how many I should authorize? Router RIP.
So I don't see what you are typing.
You don't see?
Okay.
Now you can see router RIP. Okay. Network. Which are the network I should configure? First, say configurable 20 network. Then which network, guys, I should authorize? Who will tell this
Loopback.
answer?
The loopback.
Okay, 192.168.
3.0.
Then next,
One loopback.
192.168
okay, 4.0,
4.0, 5.0,
5.0,
6.0.
6.0. Perfect. Show IP route. Okay, you can see show IP route. If you want to see the specific what you configure, show IP route. Okay, RIP. You can see this all network has learned. One network has learned. Administrative value is 120. Okay, and 10 network. Everything has learned. Okay, let's check with R1. Show IP route RIP. Look at this guy has learned everything. You can see, right? All the network. So 2 network is router 2, 3 network is your router 3, and these all the loopbacks. So these all are the loopbacks. Correct, guys? Can they able to ping now? Can I ping to loopback from here, guys? I'm in R1 now.
Before you proceed,
Yeah. Sorry.
can you minimize the CMD?
Sorry.
Okay, I wanted to know the network 20.0.0.0. Don't see it on the
20 network.
I'm able to see the 20.1, but the 20.0.0.0.
It's there now here. See here.
It's the same one. It's a /8.
Ah, okay, noted.
Okay, so let me ping the loop back 192.168.3.1. So
Can he
3.1.
ask you critical question? This guy asked you a good question. He asked you 20.00. I didn't see, right?
Yeah, it is showing now. It's showing there. Show IP route RIP.
Yes, he asked. He said we use it 20.1.1, but here we see the total class. That's why we see 00. The RIP is only showing total class. That it's class A, so the rest it can
See,
learn by only.
This is which class? This is class A,
A.
right? Okay, so class A starts from where? 20.0.0.0
Yeah.
/8. Okay, it show you only the class AIP address. It's showing perfectly.
Not
It's
the
correct.
specific IP.
This is the IP address. This is the IP address.
Yes.
That is not the network.
Yes.
Same like that. See, we can see right here. We can see this side. So what is the network ID for this? So 192.168.2.0/24.
That's correct. The RIP
Correct.
only shows this.
And what is the IP
So-
address? 2.1 is IP address for this. Yeah, you're asking something. Yeah, go ahead.
The subject is complicated.
What happened, man? You're following me? This is the network, man. This is the two
The
network.
IP network.
Okay, so because I already have written right here. This is 20.0.0.0/8. See here, already have written here. Can you see? This I have written everything here. This is the network ID. This is we'll call it as your network ID. And these all things. What is the network ID for this IP address? This is 3.0/24. What is the network ID for this? 4.0/24. What is the network ID for this? This is 5.0/24. And this is 6.0/24. Got it, guys?
Okay. Now we are together.
Okay. Okay, so now I think you can able to communicate with all the PCs, right? We can ping from anywhere. So example, these a laptop to this router I can ping. Okay, so I have the reachability. So from this desktop to this server, this desktop to this server. Okay, I do have the reachability. Okay, so I can ping to all my loopbacks. So ping 192.168, so example 6.1. I do have the reachability. So let's check from the PC side. Let's open my laptop here. Okay, I will go to desktop, command line. I'll ping from my loopbacks. So 192.168, 6.1. Okay, so I have the reachability. Okay, packet sent 4, received 4, lost 0. Okay, same thing I can ping to 4.1. Yes, I do have the reachability, right? Okay, same thing for 5.1. Right, and same thing I can go for what is one more is 3.1. Okay, so now can we attach one PC here? Let's do that. So let me connect one desktop here. Let's connect automatic. Okay, if I attach one PC here, so what is the first step I should do, guys, here? So what I should do here?
It is router, so you should assign IP address for the, the port which you connect from
Yes.
the router side.
Okay, so I should give the IP address, interface gigabyte 0/0/0. Okay, IP address. So what IP address I must give? So can I give 192.168, say example 7.1? Okay, so I say no shut. Okay, and my PC IP address, I will give manually. I say 192.168. This is my 7.1. Okay, this is my 68 7.1. So can they ping? This PC can ping to router 1 PC.
No.
So example 1.1. Why?
It should be, the network should be explained inside the
Okay. So timeout, request timeout. So what we should do now?
go to RIP configuration.
Clara, can you tell me? So what I should configure here?
We should allow the 7.0 network on the router.
Okay. Clara, you tell me. Let's ask Asma, are you there? Let's ask to one more girl. I think she's there. Yeah, I think she's there. Yeah, Asma, you tell me. I think Angie also is there.
We go to router RIP,
Okay. A router RIP, then
network 192.
network
192.168.7.0.
7.0. That's it.
Yes.
Perfect. Now 7 network should come here, right?
Yeah.
Okay, I think let's check. Okay, so we got the 7 network. Right, so I think I can able to ping to 7 network, 192.168, 7.1. 7.1. So what about this PC? Can I ping? The previously it was not pinging, right? Now it has to ping, right?
Yes.
Yes, we are getting reply. Understood, got the RIP? Any questions, guys? I will save this file. Okay, I will send you this RIP one. Okay, you want both the files, guys? I will send you both the files, lab file and the command file. Okay, after this, we're going to start the EIGRP. Okay, once I send this, we will take one small break. Do you want break, guys?
Yes.
Okay. I'll go to preference, export this one. This is RIP, right? Okay, RIP lab 3 using 3 routers, right? Text file. Okay, so let me send you right away. Otherwise, I'll get forgot, man.
Sir,
Yeah.
we need to save in each router. We need to just use a command. Like in real life, when we save like this, we will lose a lot of things. So we need to use copy command in each router.
Yes, yes. Okay, so the lot of labs there, man. TXT and these two files. This is the current lab. Okay, guys, please download immediately because once if I close the sessions, it will get, we cannot download this. Again, I should share this separately. This is the RIP using the 3 routers. Okay, now I'll open the other file. Okay, let me open this text file. All of you got it, right?
Yes, yes.
Yeah, so you want the static routing as well?
Sorry, sir.
Static routing?
For the RIP, for the today topic.
Yeah. No, the lab, what we did now, you want that one also, right? RIP lab 1. Okay, for the lab 1, yeah, this is RIP lab 1. I think for the text, we are not yet open. RIP lab 1. And this, I will send you the separate file, command file. Here is RIP lab. Okay, so we will take break now. Do you want break, yes or no?
Yes, sir.
Yes, sir.
Yes.
So after break, I'm going to start, that is your EIGRP and OSPF.
Sir, how much time, sir, take break?
Just 15 minutes, 15, not 50.
Yeah, okay, sir.
Okay, so let me put it like this. Small tea break or coffee break. After break, EIGRP, OSPF, man. Yeah. Okay, guys, then we'll see you after the break now.
Okay, sir.
Okay.
Yeah. Okay, guys, so now the topics I'm going to discuss about the next topic is I'm going to discuss your EIGRP, okay, and MD5, and how does the EIGRP works, and some theory part we shall discuss. Then we'll go for the OSPF. Okay, then OSPF LSA types. And we'll also discuss MD5 authentication in OSPF. How does it works? And LSA types, we shall discuss all 7 LSAs. It's very important, guys. OSPF is quite very important. Most organizations, they are using OSPF part. Then we shall discuss about the redistribution. So redistributions, where we are going to do that total 3 labs. Okay, redistribution from RIP to EIGRP and RIP to OSPF. Okay, then OSPF to EIGRP. It's all 3 labs we are going to discuss today, guys. Okay, so a lot of lab, guys. As you know that every lab and will be shared to you. Don't worry about the lab part. So let's discuss like what is the EIGRP. Right now we are dealing with the lab. Okay, this is a new topology what I written here. Let me start right from the basic now. So what is EIGRP, guys? EIGRP stands for your EIGRP.
Raj, is it enhanced interface gateway routing protocol?
Yes, perfect. Okay, it is an enhanced interior gateway routing protocol. It was the Cisco proprietary, guys. Cisco proprietary means Cisco people, they have developed the EIGRP. Okay, it is an advanced version for IGRP.
What's the abbreviation for?
Sorry,
EIGRP?
sorry. I
What
not
does it stand for?
no, I have not.
Advanced Interior Gateway Routing Protocol.
Yes, I will write it down here. Don't worry.
Yeah, yeah, okay.
Okay, so I'll write it down here. So the long form of EIGRP is okay, that is one. Okay, some of the important points I want to emphasize. This is the advanced distance vector. Okay, we'll also call hybrid. Okay, it was a Cisco proprietary, now it is open standard. The second point. Okay, let me write it down with the pen itself. Okay, the second point is what we'll call it was a Cisco proprietary, guys. Now it is open standard. Okay, so it was a Cisco proprietary. Means Cisco people they have used. Cisco proprietary means only these EIGRP can be configured only on Cisco devices. We cannot configure in other vendors non-Cisco devices like your HP, Dell, or any other vendors. We cannot configure the EIGRP. Now they have made it open standard. Now they can able to configure your EIGRP in all devices. Okay. The third point is it is a classless routing protocol. It is a classless routing protocol.
What do you mean by saying classless?
Okay, if there is any, it means it will going to support for your subnet mask also. If it is the network is subnetted, okay, that one also it will support. Supports your subnets. Okay, that is your VLSM, variable length subnet mask. Okay, the maximum hop count, okay, hop count for EIGRP is how much? Okay, it is support up to 255 hop count. What about RIP, guys? How many hop count for RIP? 0 to 15. Okay. Okay, by default is 100. Okay, and next point
So
is
sir, you can, hello, Taj, you can know the hop counts by doing a learning a trace command,
trace command.
present command to know the number of hops.
Yes, we'll work on that. We can do that.
Okay.
So AD value is for EIGRP is 90 administrative distance. Okay, it is very easy and easy to configure. Easy to configure and it is more flexible. So more flexible for network design. Okay, like unlike your OSPF. Okay, that we are going to discuss in coming session now. Okay, what is a multicast IP? Anybody? For EIGRP? Multicast IP for EIGRP? Two to 4.0.0.10. Remember, guys, this one. This is my multicast IP. How it will discover its neighbor. Discover the neighbor. So how it will discover the neighbor? Okay, so let me explain this. How does it works? So imagine, okay, so this is my two router I have connected. How it will EIGRP will form the neighborship. Okay, this is my R1 and this is my R2. Okay, as you know that, okay, when say example, this is 1.100 network and this is 2.100 IP address. Okay, what it does means, okay, it will send the message to router 2. Okay, I am, okay, 1.100. Okay, who is there in the link? Who is in the link? Okay, by using which IP address? It use this IP address, that is your multicast IP 224.0.0.10. Okay, okay, this I am 1.100. Okay, who is in the link? Now, this guy, what he does means this guy will reply. So what he will reply? He'll reply with the unicast message. He'll reply with the unicast IP address. See, example, I am 2.100. He say hello. He send the hello message. Then they form the neighborship. Okay, they can build your neighbor table. Okay, this is how it is very useful for every, as I told you that for every protocol, they must have some multicast IP for initial configuration. Understood, guys?
Yes.
Okay. So now, what are the table formed by your EIGRP? Table formed by your EIGRP. Which are the table formed by your EIGRP? Which are the table, guys? Who will tell? Srisha, Rahul also joined today. Srisha.
Yes, Taj.
Yeah, tell me, what are the table formed by EIGRP?
Tables formed.
EIGRP table.
1 minute.
Google it, no problem.
Yeah.
Neighbor table.
Neighbor table.
And I think IP routing table.
Neighbor
And the
table. Neighbor table. Then
topology.
second one.
Topology table.
Topology table. Then
IP routing table.
routing table. These are three tables formed by EIGRP.
Yeah.
Okay. Then what next? What are the other parameters for EIGRP? By default, EIGRP, what it does? It will calculate
Bandwidth.
bandwidth. What will calculate by default? Bandwidth and delay. bandwidth and delay. But default, it will calculate. But manually, if you talk about the EIGRP, okay, it is totally depending upon your K values. What are the K values, guys? We have the 5 types of K values: K1, K2, K3, K4, and K5. Okay, who will tell this? Who will tell this? Srisha, Rahul, Malis, are you there? Malis, I have got other two Putin students. Malis, or let me read out the Lungano, Edude, Clara.
Taj, K1 and K3 are having a value of 1. K2, K4, K5 are set to 0.
Mhm.
Component bandwidth load is this one, sir?
Yes, yes. Who is this?
Rahul from this side, sir.
Rahul. Okay, good.
Yes, sir. Bandwidth, load, delay, reliability, and MTU.
Fine, very good. Okay. So first thing is your bandwidth. Second one is your delay. Okay, K3 is your load. K4 is your reliability. Reliability. BALITY, reliability. Okay, K5 is your MTU. MTU means maximum transmission unit. But by default is going to calculate, if you're not configured these values in EIGRP, by default is going to calculate your bandwidth and delay if you're not configured anything. Understood, guys? You have to remember this. Okay, guys?
Sorry, can you just go back to the thing on the K values independent with bandwidth and delay?
Bandwidth. Okay, so bandwidth is nothing but your pipe thickness. This is the thickness of the pipe, and this is your bandwidth. Okay, and delay will be depending upon the size of your pipe. This is nothing but a delay. And load will be depending upon number of traffic you are passing in your pipe. That is your link. Link might be your gigabytes or optical fiber cable or your this thing fast Ethernet. Which cable you are using? Reliability. For the reliability, remember, guys, your EIGRP is a very fast routing protocol compared to OSPF and RIP also. Okay?
Repeat, Yapu.
For
Repeat reliability.
Reliability, it use RTP protocol, reliable transfer protocol by EIGRP for the reliability. Okay, the TCP RTP, it has been derived from your TCP IP. That's the reason EIGRP is a very reliable, and even it is a very fast protocol compared to OSPF and EIGRP. Remember that. And maximum transmission unit will be depending upon your bandwidth. Maybe you are using your optical fiber cable. Okay, your gigabytes cable or your fast Ethernet, depending upon what kind of cable you are connecting. It's as simple as this, guys. Say example, okay. So this is my highway road. Okay, you will be having a lot of tracks inside. Correct. In this track, okay, one they will fix the different speed. Okay, what happens if you have the small road? Okay, so here, what is the difference between this road and this road, guys? What is the difference between this road and that road?
The concept that the other road will be able to consume more bandwidth rather than the one which has a smaller size. But
Okay, here, first tell me what is here. You have the less bandwidth, right? You have less bandwidth. Okay, even you have the less load, he cannot carry the huge load. Delay also more, and load also he cannot carry more load. Okay, reliability, it is a reliability, but your latency time will increase because the bandwidth is very less. Like in African country, in your country, guys, suppose in the internet, what highest speed has been, I think 50 Mbps. In South Africa, so when I was there, it has in the 50 Mbps, like 2-3 years ago, so when I was there. And maximum transmission, say example, this is a maximum transmission unit is 1000 Mbps. Suppose if you consider this one, okay, if you take, this is nothing but your 40 gigabytes per second. What happened here? Okay, bandwidth is high and delay also take less time, because the lesser the delay, okay, the communication will be traffic will move very fast because of the big pipe. And load we can transfer as much you can, depending upon your this thing. So as per these things, so we can up to say example, I think 5,000 PC, 5,000 PC traffic we can generate. We can pass this in 40 gig with high speed, right? If you talk about latest one, now we are into 100 gigabytes per second, the pipe size, especially for optical fiber cable. Okay, if you talk about this is your gigabytes, okay, so everything will be, it takes a lot of time. But the good advantage of, even if you have the less pipe, is the EIGRP has got very reliable because of your RTP protocol. Okay, reliable transfer protocol. Okay, understood, guys?
Yes.
Any questions here?
In case of this, we have mentioned of the 100 gigabyte link, or maybe the 1000 gigabyte link. Do you have like a proper formula that you can calculate? Maybe you can troubleshoot if you have too much resistance in your network, or maybe there's something to do with you talk of maybe the latency or that MTU, or maybe delay or bandwidth. Maybe you need to increase the bandwidth of your particular organization.
Yeah, so that we can do in the lab for when we do the redistribution lab.
Okay.
In redistributions, okay, which we are going to configure, especially from EIGRP to RIP, okay, and EIGRP to the OSPF, where we are entering this all K values. We are going to enter this all the K values. So they will be the default values. Okay, maximum transmission unit is by default is 15,000. And your bandwidth will be depending upon the cable connections. What kind of cable connections you have done the connection for your internet, especially from internal network from one router to other router. It's all depending upon that.
All right. Then we'll proceed after. We'll look into that during the distribution.
Yeah, we will do that lab, no problem. We will do this redistribution lab. Today itself we'll do it. Okay. Okay, now. So I want to explain about the EIGRP convergence. Okay, which algorithm we are using, guys, here in EIGRP? In EIGRP, which algorithm? So we are using which algorithm, guys, in EIGRP? Rahul, Sirisha?
I think MD5.
Which algorithm in EIGRP?
MD5, I think.
Huh?
MD5.
MD5. MD5 is algorithm. It is the encryption of your key. This is not an algorithm. It is a message digest. This is your message digest file. This is not the algorithm. It is an encryption format to check the security between the two different networks, so that you should not get the unnecessary update. You should get the only authorized advertisement from your neighbor network. Remember that, guys.
Taj, how about distance vector and link state routing protocol?
Link state routing protocol is a OSPF.
Okay.
The OSPF is your link state. Rahul, let me introduce the few of some African students which are there here.
Yes, sir.
Yeah, so because everybody new days coming, I have with me Isaac from Malawi. Isaac
From Tanzania, so.
Isaac from Tanzania, and Andrew from, I think, Malawi, Angie from Malawi, Asma from India, and Clara is from Malawi, Edude from, I think, Cameroon, Lungawe, I think, from Malawi, Malice from Ethiopia, and Pawan is from India, and Sahil Ghani is from, I think, Malawi, and one more guy, VKLUV. Very difficult, guys. You just pronounce your names, guys. And I have, how do I this pronounce your name? WKLULUA.
No, it is, sir.
It's Wilson Kalua. So it's just W Kalua.
Kalua. W silent.
Wilson
W
Kalua.
silent. W
No.
K.
Yes, Taji. I'm from Malawi, the warm heart of Africa.
What? Yeah, yes, man. Malawi, I'll come to your country, man. No problem.
There are flights here. There's the fridge cyclone has affected us heavily.
Yes,
We
yes.
are blocking.
Yes, I saw the news.
We're heavily blocking here.
Yeah. I know, because I heard, I think, on the news, I think. Just now, in the break time, I saw the news. Okay. So now let's discuss. I hope up to here you understood, guys. EIGRP convergence. Okay, guys, remember, guys, this is quite very important point what I'm writing. So EIGRP will send the incremental update. Incremental update. Okay, it will send the periodical hello message every 5 seconds. Okay, and that time is 15 seconds. I'll explain what is this. Okay, and the convergence rate. Okay, the convergence rate is the 15 seconds. Now, how does it work, guys? First understand, guys, here, then I will explain what is the best route. We'll call it as a successor. Okay, and what is a feasible successor in EIGRP. Guys, please pay some attention. This is quite very important. Okay, let's say how the router, the two routers are connected. So this is my R1, this is my R2. Okay, so your EIGRP, say example is already they form all the routing table. So both they maintain the routing table, right? All the routing table, topology table. So what are the table it form? Your EIGRP. This is your routing table, right? So here also they maintain your routing table. So example, this is my 1.0 network /24, and this is my 2.0 /24 network. So as you know that it maintain routing table. What happened when they, before forming the neighborship, so router 1 will send hello message, right? Okay, how it will form by how it will send this hello message by multicasting, right? What is the multicasting IP for this? 224.0.0.10. Now they'll form the adjacency. Okay, this is we'll call it as your neighbor table. Now what I'm talking about now. Now what happened when they exchange their updates? Example, so these they have exchanged the update here, and this guy will also send the update to him. Now both this guy also available in 2 network, and here also this guy has got the 1 network. Now both they got the network. They have the communication with each other now. So every PC, say example, so here I have connected some PCs here. Okay, they can able to communicate with each other. Now, what is this incremental update? Every 5 seconds, it send your message whether this router 2 is alive or not. Okay, it every 5 seconds. This is the interview question, guys. Most of the company they ask. Okay, so maximum dead time is 15. Okay, within 15 seconds. Okay, if this guy has not replied, router 2, what is going to do? He will remove this routing table from his routing table. This update, what he has received, it will remove it. Means then there is no communication between these 2 pieces. There is no communication. Understood, guys? It's as simple as this, guys. Say example, okay. Let's say I have with me, I have the Clara. Say Clara, like I'm keep on talking to the Clara. We have the communications. Okay, so every 5 seconds I'm talking to the Clara. Clara, whether you're following me or not, I'll keep on asking. You are understood. You're not understood. Okay, so if she not reply to me after 15 seconds, what I will think that, okay, she's not responding me, I'll remove her all the details in my routing table. But
So
yeah,
you remove her after 15 seconds.
sorry,
You remove Clara from your routing
Yes.
table after 15 seconds.
yes, within
Okay.
if within 15 seconds you don't respond to me, what I'm going to do? I am going to remove your all the details in my storage routing table. I'm going to remove it. Understood?
So the 5 seconds, what about the 5 seconds is the one for communicating
5
from
seconds.
router on?
Every 5 seconds, it keep on sending. Every 5 seconds, it keep on sending. Every 5 seconds. That's the reason I think you have noticed. I'll keep on asking guys, you followed, yes or no, tell me you understood this, because this is nothing but your hello message. What happened? Because this guy's link is down. What happened? The link is down. It will wait up to maximum 15 seconds. In 16 seconds, okay, this router 1 will update himself. Okay, fine. The router 2 network is not responding me. Maybe he is dead. Understood, guys?
Yes.
Now,
Yes.
now, okay. Now, who is going to do this job? This is going to do by your algorithm. Which algorithm, guys?
It will be do.
Bellman-Ford algorithm. Okay, guys, this is quite very important. This is algorithm who is going to do this job when you configure the EIGRP. Okay, guys.
Bellman-Ford.
Yeah, Bellman-Ford algorithm. Okay, so next jump for the other topic now. Then we'll go for the lab. So let me draw one. Let's draw a topology, guys. So let's say, example, I have this router. So this is how I'm going to connect it. So example, this is my A, B router, C, D, and E router. So they all are connected. So my handwriting is not good, guys. Please understand. Now I'm talking about, okay, what is how EIGRP will select the path, best path. Okay, the first thing is best path, best route. So best route, we'll call it as a successor route. Okay, then second route. Okay, second route, we'll call it as your feasible successor. Means alternate route. How it is going to work it? Okay, as you know, as I told you that it use Bellman-Ford algorithm to calculate the best route. The best route will be depending upon your link speed. What kind of link you have connected? Maybe you are connected your fiber optics cable. Okay, here you connected with serial. Okay, say example. Okay, the cost will be calculated based the lowest cost is the best. What is the cost? Cost is nothing but the link speed. The link speed. The lower the cost, the best the route. Okay, for optical fiber cable, they have given the cost is 4. For serial, I'm not sure. I think serial, I think they have given around 12. And for other like gigabytes cable, I think they have given 8. And this is 4. And this is this is also 8. And this is also, we can say 18. Now you tell me which is the best route now. As per this one, the lower the cost, the best the route. Means this is the best route. Now this is called, we'll call it as your feasible successor route. And this one, because to reach to this C network, how it will calculate? 4 plus 2, how much? 4 plus 2 plus 8. How much, guys? Total? 24, right?
24.
To reach to this C router, okay, the cost is 24. Okay. Now to reach to this way, 18 plus 8, how much here?
26.
How much?
26.
26. Now this route will become successor route. Now this route will become your feasible successor. Understood, guys? I hope this is clear, guys.
So in terms of mesh routing, not mesh routing, but mesh networking, in terms of all the routers, assuming that A is connected to D, A is connected to C, B is connected to E, the best router, best route of the successor, it also calculates based on the route, because it might seem like in the mesh connectivity E is down and you want to connect to the other router whilst the link was connected through E.
That depending upon the topology, how you are going to design it. So right now I have taken the 5 routers. Okay. So it will, you are not going to calculate anything here. So your EIGRP is going to calculate that. You are not going to do anything here. Automatically it will calculate. But in case but as I told you that, but default it will calculate the load balancing.
Yes.
It does the load balancing. Okay. Now next thing is the EIGRP, the metric calculation. So how it will calculate the metric? Okay, as you know that it will depending upon your K value. Okay, metric. How is going to calculate is this is some standard formula, guys. Okay, that is K1. Okay, into 10 to the power of 7. Okay, divided by your bandwidth plus K2 plus bandwidth divided by 256 minus load plus K3 into delay. Okay, into 256. This is how EIGRP is going to calculate the metric. Okay, I think
So
K
what does K stand for in that case?
What is K? I told you, right? What is the K1? We can see this one, right? Let me write it down here. K1 is equals what?
Bandwidth.
Bandwidth. K2.
Oh, okay.
K2 is
Delay.
K2 is delay. K3
Load.
load. K4
Reliability.
reliability. K5 is your MTU, maximum transmission unit. This is how, okay, your EIGRP is going to calculate the metric. Understood, guys?
Sorry, sir. After plus K3 times bracket delay or dy for the metric formula.
You're talking
Sir,
about this one.
Yes.
Just into. Okay. Just into here. Delay into 256. What is the 256, guys? Luano. You tell me, man, Luano. I remember your name last week.
It's the maximum size of the network.
Sorry?
Something like that. It's a maximum number of hosts.
No.
256.
Maximum number of hosts?
The maximum number of
Maximum number of what?
IP addresses.
I think this one is for hosts. No, not host, but the network. Hop count.
I told you, right?
HOP count.
EIGRP maximum hop count is 0 to 255.
Including 0, like 256.
Okay, right? And what about RIP, guys? What is the maximum hop count for RIP?
0 to 15.
50.
Means that there is an enhanced interior gateway routing protocol. This is an advanced version of your RIP. Before EIGRP introduction, they had introduced one more routing protocol, EIGRP, Indirect Gateway Routing Protocol. Now we are not using this; it's outdated. So some organization, most of the organization, they go for EIGRP or OSPF. This is the 256 maximum number of hop count. Remember, guys. Okay. So can we jump for the lab now?
EIGRP is only for Cisco. It's proprietary, I think, right? Sir?
It was Cisco proprietary. It was.
Yeah, it only works in Cisco route.
Someone has written here.
By the way, on terms of the routing table, the neighboring table, does it have a maximum capacity it's supposed to hold, or even a router to hold? So not switch, but a router is supposed to hold, maybe in terms of neighboring table.
Means you're talking about the maximum hop count or what? Like how?
No. I'm talking about the routing table, or maybe the neighboring table. Since the router is supposed to hold those tables, so does it have a maximum records it can hold in the routing table, or maybe the neighboring table?
No. Routing table is different, guys. Routing table is different. Routing table, what information you will be finding? Routing table, you will be finding your neighbor networks. The router which is connected, how many networks it has been connected, only that network update is available in your routing table.
Yes, correct.
Correct.
Yeah, but I think it has got some maximum number.
Maximum number of count means, see, as I told you in the EIGRP, in the RIP, right? Okay.
For RIP is 0 to 15, as you have said.
Okay, is a 15, right? Like 15 hop count.
Yes.
Okay. In EIGRP,
for hops is 256.
256.
Yes, but now I'm trying to understand, because the neighboring protocol, the neighboring table, there are records which the router needs to know about the other routers, about their network. What is it like if they are communicating, if they initiate a hello and they get a synchronous hello to say that this is my network. So does that router have maximum records of the neighboring routers?
It's
because
not,
if you get,
it has got, man. It is there. Because the maximum hop count 255 means that is it will reach up to 255 means we can connect enough, because in one router, I think how many PC we can connect, up to I think 255 PC we can connect it.
Yes,
if you talk about 255 into 255, how much?
So many.
I think Malice, he's very good in maths. Malice, you tell me how much, man? Malice?
I'm taking calculator, sir.
Man, you are maths. You are good in maths, then you're using calculator.
65,000. Around 65,000.
65,535. PC you can connect in EIGRP up to 255 hop count. What about this one? So 255 into 15 in RIP. That is enough, right? There's no company which has got like 65,000 computers connected in their organization.
Yeah, correct.
Correct, right. I think maximum you will connect only, I think 10 to 15 routers or 30 or 40 routers. That's it, maximum. But still is not sufficient, is already reached. That's the reason they have migrated to OSPF.
All right.
OSPF has got unlimited hop count. Unlimited hop count. Can we jump for the lab now?
Yes, we can proceed to labs.
Okay. So can I use existing topology, same topology? so that it will
Takes a lot of
less
takes
time
super time.
to design topology.
Yeah, yeah, you can use that one.
Yeah. So
But you should just separate it so that we can at least
yeah.
tamper with
I will do that. Okay, this is
Sure.
one. This is the RIP we configured. So just I will change with EIGRP. This is my EIGRP. Okay, so I'll be you configuring. Let me write it down the heading. Okay, so let's configure. The configuration is quite very easy. It's not much complicated. Show IP route, check which are the configuration we are running RIP, right? Just remove the RIP configuration, go to global configuration mode, a row, no router RIP. That's it. That's it. Just write, save. Okay, same thing, you do it here. Okay, so go to global configuration, no router. Yeah, router RIP. Show IP route. Okay, now everything is removed. Okay, the IP address is assigned already here. So let me make it big here. Okay, so now we can see Pawan, are you there, right? So Pawan, you're listening. Pawan?
Yes, sir, I'm there.
Yeah, fine.
Okay.
Just follow these things.
Yeah, everything I followed.
Yeah. Okay, now how to configure the OSPF, guys? First understand, okay? So same thing how you configure the RIP, okay? A router, if you type the question mark, it will ask you the EIGRP. That is, we can see right here. Enhanced Interior Gateway Routing Protocol. Okay. EIGRP. Now if you give the question mark, it asking the 1 to 65,535. What is this? This is the autonomous system number. Means when you configured here, say example here you configured EIGRP. EIGRP 100, okay, and here also you should configure EIGRP 100 only. Remember, guys, this. If you change this value, they'll not form the neighborship. They'll not form the adjacency. Remember, that is called autonomous system number. Which autonomous means independent. Say, so let's say I'll give 100. We can give any number between 1 to 65,000. But when you want to communicate with the neighbor router, so you must use the same.
I don't understand the 100 number. It's what the administrative distance or what?
No, that is not administrative distance. That is the autonomous system number. The meaning of autonomous is independent. Okay.
Just like
The
the
same
EIGRP ID that we give, so that each network should communicate to communicate to each other. They must be the same this autonomous number.
So they should be able to communicate with each other. Okay. Now, this we need to do authorize your network. Same thing, your RIP. So 192.168 1.0. Then give the question mark. Now here is asking EIGRP wildcard mask. Okay. Wildcard mask here is option because in our network we have not done any subnets. Correct. We have not done any subnets inside. If you want, we can give the wildcard mask. What is the wildcard mask for these guys? Who will tell this one? What is the wildcard mask?
0000255.
Very good. Okay. Then one more network, that is 10.0.0.0, then 0.255.255.255. That's it. EIGRP's configuration is done. Show IP route EIGRP. So now it's not showing anything, right? Now it's showing empty. Okay, now we should go and configure with this router now, router 2. So go to global configuration mode, router EIGRP, we should give same value 100 here. Okay. Network 192.168.2.0. Okay, wildcard mask is 0.0.0.255. Okay, one more network is that is 10.0.0.0, then 0.255.
What is it wrong? This file.
As we can see, okay, EIGRP 100 neighborship new adjacency has been formed. Type N, show IP route. We can see D, right? D means what? EIGRP. Okay, EIGRP, one network has been learned. What is our administrative distance? 90. Right, for the EIGRP, administrative distance is 90. See,
Why
this
90?
is a default for the EIGRP. Administrative value for EIGRP is 90, for the OSPF 110, for RIP 120, for static routing 1. Directly connected network. Suppose example, this is directly connected. Okay, and this also directly connected. Administrative distance is 0. Okay, lowest value is the best. Okay, now this guy also formed the adjacency. If you type once again, show IP route EIGRP, now this guy also learned the second network. ED value 90, and this is, what is this value? This is called a metric. He has calculated. Okay.
Okay, sir.
So, okay, now I think you can able to ping, right? So other network. So 192.168. I'm in router 1 now. I'm going to ping your second network. Okay, I have the reachability. So I can reach to your all network. So let's check from this side. Router 2. So can I ping 192.168.1.2? Yes, I have the reachability 1.3. So what if I create some loopbacks here? Let's create some loopbacks. So config T interface loopback 1. Let's create this IP address example. I will give 11.1.1.1 255 0.0.0. Okay, I will create one more loopback. So this I will give 12. 3 plus create, I will just create only through 3 loopbacks. So this one also I want to authorize to my second network. If you check here, show IP route EIGRP, so it will not show you this 11, 12, 13 network. Next, let's configure this. Okay, so router EIGRP 100, same number. Just we need to advertise that one. So what is that? 10.0.0.0, right? 0.255.255.255 is not required. If we can give directly this one also. Let me remove this. I'll give this time 12 and 13 also. Okay, let's check this one now. You can see, right, all 3 network has learned. See, metric he has calculated automatically. You can see the same metric calculation. Because it is a virtual interface, right? Can you see all virtual interface? Whereas the physical interface, the metric value is different because it is a serial interface. The value can be given later, that I'll tell you later that one. Understood, guys? So I think I can able to ping. So ping dot 1.1.1. Yes, I do have the reachability. 12 network and 13 network. Understood, guys?
Yes.
Got clear? Your battery is so low. What, Melis? You're feeling
For
hungry?
me, okay, I'm testing my
Huh?
network. I'm testing my network. So when I configure, I didn't use the whole class A network for one connectivity. So I'm checking. I have some problems, so I have to fix.
Okay. Understood, guys? EIGRP? So EIGRP packet types. So there are the 5 types of packets, guys, in EIGRP. Okay. The first thing is hello. Okay. Second one is update. Okay. And third one is your query. Okay. And next one is reply. This is the interview question, guys. This is nothing but your acknowledgement.
The fifth one is
Acknowledgement.
acknowledgement.
Now understood?
Yes.
You have to remember the guys. If you go for any countries, like if you want a job for US or this thing, okay, they'll not ask the basics thing what I explained till now. They'll ask this thing first. First, they will ask what is the ED value for EIGRP? Okay, how EIGRP form the neighborship? Okay, then if you tell these two answers, then they will ask this question. Okay, which are the EIGRP packet types? Okay, so other very good feature for the EIGRP is load balancing. Okay, it does the two
load
job.
balance.
Load balancing on the traffic, man. Okay, EIGRP, it is nothing but a traffic police. In your country, traffic police is there, guy?
Yes, you do have everywhere.
No, how? Because if the traffic is very huge, means he will divert some traffic to other route. Okay, the EIGRP, okay, what it does means it does the equal and unequal load balance. Equal cost load balancing. Okay, and another one is unequal load balancing. Unequal cost load balancing. Equal and unequal load balancing. By default is going to calculate both equal and unequal. Depending upon this one, it will divert the topic. So example, one road is doing some damage, they are doing some work there, construction is going on. What traffic police does? Okay, it divert the traffic to other route. Correct?
Correct.
Same, correct. Same thing here. Okay, how this equal and unequal load balancing is going to work. So example, like you have the 3, let's say 4 router I'll connect. Okay, which one is connected in this way? Equal load balancing. Okay, suppose example here also it send 5 Mbps, here also 5 Mbps, and here also 5 Mbps, and here also 5 Mbps. This is called equal load balancing. Equal cost load balancing. Okay, now what is unequal cost load balancing? Okay, So let's say example X. So I have the router which is connected in this way. Okay, maybe I'll use one more router here. Okay, unequal load balance. Say example, this link is say example 10 Mbps. Okay, this is 20. Okay, this is 100. This is 200. This is 1 gig. Okay, this is 10 gig. This one also it supposed. Example, this is my R1. This is my R2. It also support the equal and unequal load balancing. I hope you understood, guys.
Yes.
Any questions? So that I can jump for next lab now. Okay, regarding the 3 lab, guys, I want you people to do this using what you have to do means just add, let's say, Control C, Control V. Okay, you just add one more this thing, guys. Here, let me delete this. This is not required. You add one more network here and configure from your side, guys. I will share you this this topology with all ready meant. Just we need to do the lab directly from your side. Okay, I will save this. I will share you right away, guys. So let me open this command. What are the commands? Why Clear has? Okay, export this and this is EIGRP. I think EIGRP now file is here. No? Where is EIGRP now? Okay, so let's see. What is this file name? Okay, this I should use. I should change this file name. Let's say save as. Okay, so I think now I will share this file, guys. EIGRP. Okay, I hope you received this file, guys.
Yes, yes, sir.
Yes.
Okay. Okay, so can we jump on the next lab so that I can explain before what is the EIGRP strub one? And MD5 authentications we'll do both at the time, guys, once I completed OSPF. Okay, so let me start the OSPF. Okay, then MD5 authentications, we'll use the same topology previously, just we'll configure the MD5 authentication. Is it okay, guys? Guys, all of you there? Or I'm talking
Yes,
to
yes.
myself?
Yes, sir.
Yes, yes.
On your camera, man, no, just I want to see you guys, whether you have got still strength, because still another 1.5 hour, one hour I want to take. I want to start the OSPF now.
I am here, sir.
Malice, you are sitting in your car, inside your car or what?
No, no. Today I'm in my shop now.
Lungano, where are you? You are sitting.
I'm here.
On your camera, man. Just I want to see you, so that I will get some energy to continue. Otherwise, you need to send a hello message every 5 seconds.
Like EIGRP.
Yes, EIGRP.
Sorry, sir, my camera is not working, but I'm active. Very active.
You are active.
Yes, my
Okay.
camera is not working. Maybe I'm using another computer. I'm trying to connect the link.
Okay, what is Andrew?
I'm available.
Okay, Andrew is Angie and Eduardo.
I am right here.
We are here.
Okay.
I'm here. But also too much is poisonous.
Sorry,
But also too much is poisonous.
too much is poisonous.
I think his brain is exhausted. We can reserve something. We can reserve something for tomorrow then.
Your brain is exhausted. Your memory
Yeah,
today.
yeah, because you know
You-
the his style of teaching is very fast. So if we grab so many things, we will not follow them. So we may
Mhm.
break for tomorrow.
Okay. You want me to stop today?
Maybe
No.
end up with OSP.
Let me-
OPS, something like
I will start OSPF. Okay. OSPF lab. Like then we can stop. Or you want me to stop? Asma, are you there? Okay.
I think we can just start off tomorrow on the OSPF thing.
Okay, because it is a 4-hour session, man. Right now it is 3 hours I have taken, right?
Yeah.
Now it is in India, it is almost 5 p.m. here. What is the time in your country then?
14.
It's lunch. It's past 1 and we haven't eaten. It's lunch hour has passed.
Okay, lunch hour passed for you. Okay. I think
Yes.
you are feeling hungry, I think.
Exactly.
Okay.
Me too. Me too here.